Let's get to welding. I got a lot of beads to run. This is a placard that's going to go on top of a display, and I'm running beads just around 3 sides of it. When you're first learning to TIG weld aluminum, 1/8 of an inch per second is a pretty good rule of thumb. When you're new, you don't want to try to go too fast. It doesn't feel comfortable yet. But as a beginner, 1 dab per second every 1/8 of an inch is about right. And that equates to about a 7.5 inch per minute travel speed. Since I'm using a foot pedal, I'm going to set the machine amperage to 200, AC balance to 32% cleaning, a good all-around setting, AC frequency to 150. For this first bead, I'm going to be trying to do 1/8 of an inch of travel per second, 1 dab per second. I'm using 1/8 of an inch thick 4943 filler metal. I was going to use 5356 filler metal, but I had some extra 4943 that was given to me by a local welding supply as a sample. It's Hobart filler metal. Got a lot of benefits and I like it. Okay, here's the amperage and the settings and all the details that it took to run a bead right next to the edge on 3/16 thick 6061. That was a fairly normal, safe travel speed, but now let's see if we can increase that travel speed to almost double. I'm using a CK20 style water-cooled torch with a number 6 gas lens. I think a number 6 is just about right for me for aluminum. A lot of people like a 5. I'm trying to shoot for roughly twice the speed here. So I'm dabbing rod about twice a second instead of once, and I'm moving as fast as I feel comfortable to move. I'm not trying to be on the ragged edge of being out of control. I'm just trying to go a little bit faster, as if this was a production part and I needed to get paid for each part. So this is more like 12 inches per minute instead of 7.5. That could be a really big difference maker. The appearance doesn't seem to have suffered at all, and that's what I've found. Sometimes going a little bit faster can actually make sort of a better looking weld because you're just not really concentrating on looks. You're just really trying to motor out, and it winds up being a uniform weld. Another thing that occurred to me on this job is maybe using pulse settings. So I set the machine to a baseline pulse setting of 1 pulse per second with a background current of 33% with 50% on time. And that's fine. It works fine. It gives you kind of a rhythm, but it does limit you. You can't really go much faster than 1 dab per second on the high pulse. You typically add filler wire on the high amperage side of the pulse so that it melts in there nicely. So you're limited on your travel speed when you use pulse. It's an option. It's kind of fun to play with, but it's not a way to really increase travel speed unless you're trying to feed at 2 pulses a second or something like that. And you'd have to feed every pulse. So I don't really pulse a whole lot on aluminum. I keep it as an option. I just don't do it a whole lot. Another use for pulse would be going back over a weld that didn't turn out the way you wanted it to. Certain industries like aerospace use thinner metals, and the testing sometimes requires X-raying. Now on an X-ray weld, too fast a travel speed can trap gas and cause porosity. Oftentimes, test welds done for the aerospace industry are done in a fixture like this, which is a chill block, which speeds the cooling rate. So every time you dab rod on a test like this, you need to kind of just wait for half a second or so and let things kind of smooth out and outgas. When you're welding in the 3G or vertical up position like this, your travel speed kind of automatically slows down. What you have to remember is each ripple in that bead is a freeze line. That means when you add filler metal, it chills the puddle a little bit. So waiting around for just a half a second or less, letting things kind of normalize, letting things outgas if they want to, can kind of help you prevent porosity on a test weld. If you do have a test coming up like this in your future, these next few seconds should be very valuable to you. A full penetration butt joint like the one you see here is most often tested using X-ray. And porosity is by far the most common reason for failure. Porosity is caused by trapped gas, and that could be from oxides, it could be from hydrocarbons, it could be from impurities in the sheared edge. Even on a full penetration weld like this, where the penetration side looks smooth and even, you could have problems. A quick polish will reveal those problems. Look at all that linear porosity shown with the polish on this weld. It looked good, but because this joint wasn't cleaned properly, there was way too much porosity for it to pass X-ray. A typical sheared edge looks something like this. There could be lots of oxides and oil trapped in that, so using a deburr tool or a clean dedicated file is one of the most important things, one of the things that makes the most difference on X-ray results. Of course, it helps to clean it with a wire brush. It helps to clean it with acetone. It also helps to use a slightly slower travel speed to give the bead time to outgas any impurities that might be left over. In this case, just pausing for a half a second or so after dabbing filler wire can help. This bead looks okay, but let's test it out like we did the other one. A Scotch-Brite pad on an angle grinder will reveal whether there's porosity or not. And the only difference between this and the prior weld was cleaning that sheared edge. Let's get back to that placard though. I wound up settling in on that faster travel speed. Found that the beads looked every bit as good when I was motoring on at 12 inches a minute than at 7.5 inches a minute. Since I was using 1/8 4943 filler metal, I didn't have to worry about my filler rod hand keeping up. And because I was using a number 6 gas lens, it kept the tip of that rod shielded really well.
Weldmonger.com is my online store.
That's where you can find the original TIG finger made in USA. We also carry a lot of other TIG accessories like TIG torches, TIG machines, tungsten, TIG kits, filler metal, gloves, and more. And we have tons of videos showing how to get the most out of our products.